All right, good afternoon. You're welcome to today's lectures in pharmaceutical calculations revision. In our last class, I told Gideon that you guys should select questions from that 1,100 questions we have in each of the topics. I gave him the pattern, the number of questions from each topic of your choice. We use as what? Revision. So from now till your exam is first week of October, I think our last contact should be on 8th. 8th October is Sunday, right? I think our last contact should be on 8th October. That will be our last contact. Then the following Monday, you write your exam. So I want us to, from now till then, what we'll be doing as you come, all the questions, just get questions from any of those questions you don't know. Am I communicating? Any of them you don't know, you want to be clarified on. There's a particular number of questions I want you to, because of time, I want us to look at in each of the topics. So that's what the instruction I gave last time. I don't know if you have done that. Good. All right, let's start because we have barely 1 hour 15 minutes. All right. Which topic are you starting? And just start from any topic, no problem. Call the question. No, just dictate the question. Let me hear the question.
Calculate A value.
Okay. The question. Okay. The first question says calculate E value for each of the following, given that the number of ml of water shown will provide an isotonic solution from 0.3 gram of the drug substance. So the drugs, they are as follows. First one is apomorphine HCl, 47 ml. Second one is ethylmorphine HCl, 5.3 ml. The third one is halocaine HCl, 6.7 ml. Last one is vancomycin sulfate, 2.7 ml. So all those mils are water, right? Now they are saying that 0.3 gram of each of these drug substances, when dissolved in the number of ml of water attached to them, they will form an isotonic solution. That's the meaning. So if you get 0.3 gram of apomorphine in 47 ml of water, to form any solution from there is what? Isotonic. If you get ethylmorphine HCl with 5.3, you get 0.3 gram of ethylmorphine HCl in 5.3 ml of water, it will form an isotonic solution. And if you get halocaine HCl in 6.7 ml of water, it will still form what? Isotonic solution. That's the meaning of all these things. Now, for us to be able to answer this question, we must all know what is E value. E value means sodium chloride equivalent. Am I communicating? Sodium chloride equivalent of a substance is its E value. And by definition, E value is just the amount of the substance that will have equal isotonicity with 1 gram of sodium chloride. Am I communicating? The amount of the substance that will have equal tonicity that will have equal tonicity with what? 1 gram of what? Sodium chloride. That's why sometimes you hear that sodium chloride equivalent of a particular compound is, let's say, 0.2. What it actually means is that 0.2, the amount of sodium chloride, am I completing, that will be equivalent to the 1 gram of that what? Substance. It's the other way around, please change it. Is the amount of sodium chloride that will have the same tonicity with 1 gram of that what? Substance. Sorry, I change it. The actual definition is that, I said before that, so listen to what I say so you understand where the mistake came from. I said before that sodium chloride equivalent of a substance is the amount of that substance that will have the same tonicity with 1 gram of sodium chloride. But it's actually the amount of sodium chloride that will have the same tonicity with 1 gram of the what? Substance. Are we there? So if you say that sodium chloride equivalent of a substance is what? 0.2 gram. Sorry, no, it has no unit. 0.2. What it actually means is that 0.2 gram of sodium chloride has the same tonicity with 1 gram of that what? Substance. Am I communicating? That means what it means is that 0.2 gram of that substance, that's 0.2 gram. That's 0.2 gram of that sodium chloride is actually the amount of sodium chloride that substance represents in a particular mixture. Am I communicating? Now, with this question now, you are told that these substances, we want to check the E value of this substance. What it means that we want to check the amount of sodium chloride that will be equivalent to 1 gram of this what? Apomorphine. But we also put into consideration the solution we are the solution we are working, the volume we are working with. Am I communicating? But for what the first another thing we need to consider is this: we should also consider the amount of sodium chloride or the concentration of sodium chloride that is isotonic on its own. Am I completing? Concentration of sodium chloride. What concentration of sodium chloride? Because sodium chloride is tend to be isotonic. 0.9, perfect, good. 0.9% weight in volume of sodium chloride is isotonic. That means, of course, it means what? 0.9 gram in what? In 100 ml. That's the meaning, right? Now, what it means is that 0.9 gram of sodium chloride in 100 ml is what? Isotonic. But the question now say that 0.3 gram of this substance in 47 ml, okay, what really is isotonic on its own. Am I communicating? That's what they're saying. But they want to know the sodium chloride equivalent of this substance. How do you calculate it? This one is already 0.3 gram in 47 ml is already isotonic. So we bring down this. What amount of sodium chloride in the same 47 ml will be what? Will be what? Isotonic. So let's find out the amount. We make everything to be in 47 ml. So we can actually get the amount of what? The sodium chloride equivalent of this substance. If 0.9 gram of sodium chloride is isotonic in what? 100 ml. Now, what gram will be isotonic in what? 47 ml. X is what? 0.9 gram times what? Times what? 47 ml over what? 100 ml. May cancel ml. 0.9 times 47 is what? Divide by 100. Fast. 0. What? So actually 0.04. Let me leave that 42 gram. Or let me 0.423 gram of sodium chloride. And what? Is I what? Isotonic. Now, good. The question says, E value is the amount of sodium chloride that have what? That have equal tonicity with 1 gram of this. But this one only have tonicity with, listen, is hard to say tonicity with just 0.3 gram. Hope you know. For me now, because we have brought down this to the same for 7 mil. So what it means is that 0.042 gram of sodium chloride has the same tonicity with what? 0.3 gram of what? Apomorphine. So what is the amount of sodium chloride that will now have the resistance to tonicity to 1 gram of what? Apomorphine. With that, this we did now. We brought this in. So this is isotonic on its own. This is isotonic on its own. For this to be the same tonicity with this one, we bring the volume of this to what? This. So we can get the amount of sodium chloride that will have the same tonicity. Now this 0.0423 gram of sodium chloride in this for 7 mil have the same tonicity with what? 0.3 gram of what? Apomorphine in the same for 7 mil. Are we together? Now, but the E value is the amount of what? Sodium chloride that has the same tonicity with 1 gram. If so, we now do the calculation. If 0.0423 gram of sodium chloride is equivalent to what? 0. What of apomorphine. I use AP for apomorphine. Now, we define E value as the amount of what? Sodium chloride that has the same tonicity with 1 gram. So here should be what? 1 gram of what? So we don't know the amount of sodium chloride that will have the same tonicity with what? 1 gram of what? Apomorphine. So that means X is now equal to what? 0.0423 times what? 1 gram over what? 0.3 gram. What's the answer? Just simply divide 0.0423 by 0.3 gram. What? Let's leave it in 2 decimal places, because you know that here is what? 0.14 gram is okay. Now 0.14 gram of apomorphine has the same tonicity with what? Sorry, 0.14 gram of sodium chloride has the same tonicity with what? 1 gram of what? Apomorphine. That means that the sodium chloride equivalent of apomorphine is what? Simple. Leave it in 2 decimal places. Does it make sense? So we'll solve for the next one, then you do the remaining 2. Let's solve for the next one. Then you do the remaining 2. How many questions did I point out in isotonic solution? Okay. Good night, done. Now let's look at this. We don't need to claim much here again. Remember, we have already established. Okay, yes, we need to, because this has changed too. For a morphine, it has changed to what? 5. The volume has changed to what? 5.3 mil. So let's start from here. Please look up. Help me with that, right, please. So let's start from here. We have already established, listen carefully, that 0.9 gram of sodium chloride in 100 ml is what? Isotonic, right? Good. For us to bring this to the same, to know the amount of sodium chloride that will be isotonic to 0, to this amount of what? Ethyl of it in 5.3 ml. We check the amount of sodium chloride in what? This in 100 ml is already what? Isotonic. So we know the amount in 5.3 ml that is what? Isotonic. Am I communicating? Now, so what we now do is this. If this 0.9 gram in what? 100 ml is what? Isotonic. Now, what will be isotonic in what? 5.3 ml. We don't know. We call it what? I follow it. We call it X. So X is what? 0.9 gram times what? 5.3 ml over what? 100 ml. What's the answer? 0. What?
0.0477 gram.
0.0477 gram. 0.3477 gram. Are you sure? This is 4.7, right? Are you sure it's not 0.00? Check it well. Because this one is in tens, and this one has gone down to units. They shouldn't be the same. Just multiply 0.9 times 5.3, unless you multiply 53. Multiply 5.3, let's see. Zero 0.9 times 5.3 divided by 100 is what?
0.0477.
Are you sure? Are you serious? Wow. That's where the issue came from. But you wrote here 47. We are working with what you wrote. Now, it's not true. What you wrote here 47, there's no point here. Because I know that there is no way they can be in the same place, decimal places, because you can't afford 47. So this is actually what? 4.7. Please, this is 4.7. I was working with 4. I was even working with 47, sir. But it's okay. But I don't think it reflected. You know, I was just writing what you got for me, so I don't think it changed anything here.
It doesn't affect.
No. It doesn't. It's just that you didn't put it here. Everything I wrote here, you are the one that called the answers for me, the calculation. So it don't affect anything here. It's just that me, I saw that I didn't see point here, so I call it 47. So and I now see this. You know, this is what we did in estimation. Remember, have you seen how estimation can help you to solve issues? I've not solved this thing, but immediately I said there's no way for 7 and 5 or 3 will give you answer that win the same. You know, this will be 0.004. Do you understand what I'm going to? So this is the power of what? Under 2 seconds, I have already estimated it. I know that. And that's why we're able to correct this mistake now. That's what estimation will help you to achieve. Now, okay, let's continue. No issue. So we have what? 0.047 gram. Now this one now in 5.3 ml is what? Sodium chloride is what? Isotonic, okay? Now, because you use the same volume as here, this render 2 of them iso 2 of them to have the same what? Tonicity. That means 0.3 gram of ethylmorphine in 5.3 ml have the same tonicity with what? 0.0477 gram of sodium chloride in the same what? 5.3 ml. Is it clear now? So with this now we can now come here. With this now we can now come here. Remember our definition of E value. E value is defined as what? The amount of what? Sodium chloride that has the same tonicity with 1 gram of what? A substance. Now, but here we have determined that 0.0477 gram of sodium chloride has the same tonicity with what? 0.3 gram of what? Let me use EP for ethylmorphine, okay? Or EM. No, let me use EP for what? Ethylmorphine. So 0.0477 gram of sodium chloride has the same tonicity to what? 0.3 gram of what? Ethyl morphine. Now, how many gram of sodium chloride will not have the same tonicity to what? 1 gram of what? Ethyl morphine. So, S is now what? We call it S. S is now what? 0.0477 gram times what? 1 gram over what? 0.3 gram. So, what is the answer? Please remember, you may enter into the temptation of leaving your answer in gram. Please, equivalence E value does not have a unit. Okay? It's not gram. Gram it has no units. Just remove that gram because you are comparing that this amount is equivalent to what this amount. So you don't go and put gram again. You know we mark unit here. Remember, so some of you that had issues in this course, unit affected you. Some don't put you, some didn't put unit. Then some put unit where they should not put unit. Know your unit because your unit is very important in formulation and dispensing. Especially formulation because you can make mistake and write something a wrong unit. The person that want to mix will go and take a nothing. So unit, that's why I don't joke with units. It's very important. So what is the answer?
0.159.
So X is actually what? 0. What?
159.
So just call it 0.16 gram. This is X, but this is X. But if you now want to write the E value, simply write what? 0.16, okay? So the E value of this ethyl morphine is what? 0.16. Simple. That's the E value. So I want you guys to try. I want you to try this second and last question. Let's see if we're on the same page. I don't. So this is what? That is that's 0.20 now. Gram. You're still calling gram. You're still calling gram. That is you just find what you found is S. What you just found is remember the question. Remember what E value is. The amount of this that has the amount of what sodium chloride that has what that has the same isotonicity with what 1 gram of a substance. Am I communicating? Now, if you find that S, you just find that amount is the amount you find. But if you don't want to present it as E value, there's no because it is you are just this thing is equivalent to this. Am I communicating? It's a type of it is that it's a relative value because this gram here will cancel that gram there. It's a relative value. It's not an absolute value. So you are not supposed to put a unit there. Okay? So when you are done, if you are writing your answer, just write 0.20. Don't write gram. If you write gram, you fail it. I'm telling you now, so you do. I said it in you are doing our normal class. Some people do not do it and they still fail it. But that is not the answer. The answer is simply what? 0.2. Don't put gram there. Because E value is not an absolute value. It's a relative value. You are comparing that of the what? Sodium chloride and that of the what? Substance. So the gram will cancel the gram. So it's not an absolute value that you have a unit. Okay? Good. So have you solved the other one? 8.1. How do you get 8.1? Check well. Check well. Let me see what you did. 0.9 gram. No, now you are divided by 100 mil, not 1. Check well.
This is 100.
0.9 times 2.7 alone is 2.43.
Yes.
Divided by 100 is what? Check well.
2.4.
Divided by 100 is 0.00243. 0.0234. You know, understand where the mistake came from. You didn't actually divide by 100. And you two of you made the same mistake. How come? Individually, how come? So divide by 100, then you get it, then you continue.
Hello?
Please check well. What are the question range? What are the question range? Because that 73 should not have a number. That one, that I think that should be the question, but confirm.
Yeah, 73 is the question.
So 73 question, and what's 74? Show me. Let me see.
The question being the upper hand.
That means there's something you missed now. It's from 72 to 77. There's something you missed. Watch out. Apomorphine is here. Ethylmorphine is here. Holocaine is here. You missed procainamide, 7.3 mil. Procainamide is number 76. So cancel. See what you do. Clean that 73 entirely. See this thing. Clean 73. In fact, clean no. Just clean the numbering first. Just the numbering in all the numbers first. Then apomorphine should be 73. Number 73. See marker here. Apomorphine should be number 73. Then ethylmorphine 74. I agree. Holocaine 75. Then clean that viomycin sulfate. There you should write procainamide. Procainamide is 76. Procainamide HCl. Come on, take the phone. AINAMIDE. HCl. Then 7.3 mil. Then before you now write 77, which is viomycin, VIOOMYCIN sulfate. No, clean that E after N, and then sulfate. SULFATE. F not P, but it's okay. It's not bad. It's okay. Okay, it's correct. 2.7 mil. So what answer did people get in that viomycin? 0. What?
0.08.
So it's simply what 0.0. Okay, 0.081. It's okay. So now solve that 76 for procainamide. Solve 76 for procainamide. You say that isotonic is 12 questions, right? We have solved 5 now. 1, 2, 3, 4, 5. So it remains 7 questions. You say that the answer is what? Let me see what you did. No, now you don't know that you should state this in your notes. What do you now revise? With time now you may even forget this thing you did today. You see how Hezekiah is doing his own. You solve it in your notes. Let's have a comprehensive note. Solve it there. It's very important for you. Not just today, for tomorrow's sake. So if you now want to read, because you solve it by yourself, if you open it, do your final revision, it will be easy for you to remember. Okay, let me see what you did. Okay, 0.9 gram of sodium chloride in 100 ml is isotonic, right? So how many will be isotonic is 7.3 ml of. So you got this 0.06. Okay. Then 0.06 gram. That means that 0.065 gram of sodium chloride is equivalent to what? 0.3 gram of what? Of procainamide HCl. So now, what amount of sodium chloride will now be equivalent to 1 gram? Good, perfect. So you did this and got what 0. Which is simply what 0.22. 0. Is that what you got? Perfect. So the E value of what? The E value is 0.22. All right. When you are done, please write the next question on the board so we can It's good to see the question on the board and solve it than detecting. Okay, let's look at this question. I think that's question 9. It says, zinc chloride is a 3-ion electrolyte dissociated 80% in a given concentration. Calculates its I factor. You know, if you can remember during our normal lecture, we talked about I factor and we talked about dissociation of substances. Am I communicating? Solutions are divided mainly into two. We have the one solutions that are what? Electrolytes, and those that are not what? Electrolytes. Now, the ones that are electrolytes, they dissociate. They can have up to 90% dissociation. But the ones that are not electrolyte, they don't dissociate. And those ones that are not, sort of like boric acid, something like mannitol, glucose, dextrose, all those ones, they are not electrolytes. They don't dissociate. But things like sodium chloride and zinc chloride, they dissociate. Of course, you know what is dissociation now. If you have a solid like this AP, they dissociate into their component ions, right? And plus what? Be something like that. Some may have up to, this one is a 2-ion electrolyte. Some may have up to 3 ions. 3 different. So now, what I want us to know, basically, the basic thing I want us to know here is that this is the reason why if in a solution, if electrolyte is used to form a solution, there's always that electrolyte that in solution form exert more osmotic pressure. It exerts more what? Osmotic pressure than the one that are not what? Electrolyte. You know, pressure, the more the number of particles. If we are about 100 people, 1,000 people here now, you cannot stay here. 3 of us, the pressure will be what? High. But if there's no pressure, 3 of us, the same thing now. Because this electrolyte dissociates to form ions, in the entire solution, the pressure will be much in the what? Solution. Unlike the non-electrolyte that are just molecules. So them don't even dissociate, they will just remain there. The osmotic pressure is there, but it's not much to compare with what? Electrolytes. Now, what is now this I factor? I factor, simply the ratio of the undissociated particles or molecules to the what? Say particles, the ratio of the dissociated particles to the what? Basically, that is what I factor is. Now, because non-electrolytes basically do not dissociate, you see that the number of particles undissociated is the same number of particles in the system. So the I factor is say what? 1. It's what? 1. Am I complicated? Because the whole molecule is still there. But if the one dissociates, let's say if this one dissociates 20%, for example, now, and it's a 2-ion, like sodium chloride now. Let me use sodium chloride as what? 2-ion. If sodium chloride dissociates now, they form sodium ion on what? Red ion. Most times it normally dissociates 80%. Now, if of course everything there is still intact, we call it what? 100 what? Percent. So if it dissociates to 80%, see what happens. Equal percentage of the if you say that sodium chloride dissociates 80%, it will yield 80% of sodium ion and 80% of what? Chloride ion. 3 of us. So here we have what? 80%, right? And here you have what? 80 what? Percent. Ask a question.
What then makes it 100%?
You know, if you say that something is 100%, you mean that it's complete. This is just a percent. You use percentage to represent it, not that is specific. Hoping that 100% can be 1 billion. Are you aware? If you say that what it means that it's complete, none is lost, it's 100%. If you now go to the actual quantity, it may be billions. True of us, it may be millions, it may be thousands. But the point is that if it's 100% is what? Complete. That's the meaning. Nothing is lost or removed. But if it has 80%, 80% what? Dissociation. What happens is this: 80 will leave. 80 will do what? We do what? Dissociate. And 20 is what? On what? On dissociated. Am I communicating? Am I communicating? So now, but because this is an ion, this is an electrolyte. If one mole of an electrolyte dissociates, it will yield one mole of all the electrolytes, all the ions. If one mole of the electrolyte dissociates, like if there are 2 moles of sodium chloride here now, if it dissociates, it will yield 2 moles of sodium ion and 2 moles of what? Chloride ion. That is chemistry for you. So if it has 80% dissociation, that means it will yield 80% of what? Sodium ion and 80% of what? Chloride ion. Does it make sense? Does it make sense? Now, what I define as what I define as a I factor? I said that it's unassociated over dissociated.
The ratio of dissociated particles.
No, what happened after dissociation actually is ratio, correct it, is ratio of the entire particle that is in the system divided by the initial one that started the what? Dissociation. Like now, I factor is this. Look at. The amount of particle presence. Am I communicating? Afterwards, dissociation, right? Over the amount of what? Particle before what? Before what? Dissociation. Am I communicating? Is it clear now? This is a standard what? A better explanation of I factor. The amount of particles that present after dissociation and the amount of that is what? Before it started the what? Dissociation. Now, if sodium chloride have 100%, 80% dissociation, what happens is this: it will yield 80% of what? Sodium chloride and 80% of what? Sodium ion and 80% of what? Chloride ion. What is remaining here? 20. Now dissociation has ended, right? Now what is the total percentage of the particles in the system after dissociation? 180. So I factor is now what? 180 what? Particles or percent. Do you know why you will not say particles? Because you don't know the exact number of particles there. Are you there? So you use percentage, okay? Is it clear now? Over what? 100 what? Percent. So the I factor of sodium ion sodium chloride is now what? 1.8. Is it clear now? Now, but something like those ones that are not electrolytes. Watch out. Those ones that are not electrolytes. They start with 100%, right? At the end, they will still remain what? 100%. Nothing added. Two of us. So in such case now, the I factor is what? 100% over what? 100%. Which is what? 1. That doesn't that the I factor is what? 1. Am I completing? Now with this I talk of our mind, what is the answer to this question? It's simple now. What will you say now?
1.8.
Look at the question very well. It says zinc chloride is a 3-ion electrolyte. It's not 2-ion electrolytes. No, let me solve that so you understand it. Let me solve it. Look at the dissociation. First of all, you should know the formula for zinc chloride first. First of all, you should know the formula for what? Zinc chloride. Watch out. See why it is 3. Zinc chloride is what? See formula for zinc chloride. Chlorine here is 2. Zinc is 1. So if you dissociate now, you have zinc ion plus chlorine ion plus another what? Or simply 2 chlorine what? Sorry, I mean chloride ion. Gideon, are you watching? Look at the dissociation here. Your mind is not here. If you dissociate, basically, it's actually, let me write it the way it should be and split it to explain why it is 3. This is formula for zinc chloride. ZnCl subscript 2. If you dissociate, it will form 1 mole. There's 2 chlorine here now. To yield 1 mole of what? Zinc ion and 2 moles of what? Chloride ion. Now this actually means zinc ion plus chloride ion plus another what? So it's a 3 ion what? Electrolyte. True of us. But we are told that it will dissociate 80%. Instead of the initial what is there is 100%, is complete. But when it dissociates, it forms 80% of zinc ion, 80% of the first chloride ion, and 80% of the second what? Chloride ion. True of us? True of us? Now, what will remain here? 20%. True of us? Now, what is total particles that here in percentage after dissociation? 80 plus 80 plus 80 plus 20. What's the answer? 260%. After the dissociation, we have what? 260%. Before dissociation, we had what? 100%. So I factor of zinc chloride is now what? 260% over what? 100%. Which is what? 2.6. So that's why I factor of zinc chloride is what? 2.6. Is it clear? Is it clear? So once you understand the dissociation, you are good to go. So with this now, okay, please, when you're done, let me go to the next question, so I don't confuse you. That I factor. No, it has no units. Look at it now. Percent cancel percent. True of us. No unit again. True of us. So I factor has no units. You're just comparing what is remaining in the solution, the number of particles or percentage of particles after the dissociation to what you started with. That's what it's comparing. So because non-electrolyte, they don't dissociate. That's why it will still remain the same thing. If you divide it to give 1, because it's the same 100%, no change. But electrolyte will change. More particles will be added. You not calculate the final particle that remain, both dissociated and unsociated, and divided by the what you started with. Okay, I will solve the next question, and I will allow you to solve. I'll solve question 13 now. Then you will solve 8 and 10. Let me see whether you truly understood what we explained, what I explained. All right, let's solve number 13. Number 13 says, calculate the E value for fluorescein sodium, a 3-ion electrolyte, right? Which dissociates 80% and has a molecular weight of 376. Now look up. There's a formula. You know, we are looking for the E value. There are 2 ways you can find E value. You can find E value using the first one we did, when we said that E value is the amount of sodium chloride that has the same tonicity with 1 gram of a substance, right? Now, but here now there's a formula you also use here. Here, if you are giving molecular weight of the substance, you know, in that one there's no molecular weight. If you are giving molecular weight of the substance, you find it. If you find the substance what? I factor. Am I communicating? You find the substance I factor and use I factor and the molecular weight to find the what? E value. Now, with this formula, E value, see the formula. E value is equal to molecular weight of sodium chloride. I think so, yes. Molecular weight of sodium chloride over I factor of what? Of sodium chloride times I factor of the what? Substance divided by what? Divided by, I'm coming, molecular weight of what? The what? Substance. I said that E value is molecular weight of sodium chloride divided by I factor of sodium chloride times I factor of the substance in question, right? Divided by molecular weight of the what? Substance. If you look at this question, they didn't give you the I factor of sodium chloride. You don't need to be told that sodium chloride is, I think I said it here, it's a 2 ion electrolyte. True or false? Gideon, are you listening? Sodium chloride is a 2 ion electrolyte. And I said that it normally dissociates 80%. So if a 2 ion electrolyte that dissociates 80%, what will be the I factor? Calculate it now. Check it now. 1 point what? 1 point what? 8 now. Because 816 plus the initial one plus 20% that is undissociated. 180 divided by the initial is 100, 1.8. So actually, so I factor of sodium chloride is what? 1.8. Good. So I factor of what? Sodium chloride is what? 1.8. Now the next thing, what is the, if you see, they didn't give you the molecular weight of sodium chloride, but you expected to do what? To know it from your secondary school. Molecular weight of sodium chloride. Sodium is 23, right? Chlorine is 35.5, right? Right? So which is what? 58 point what? 58 point what? 5. You don't need to be told that one. That's why they didn't include it in the question. Because you should know it. Am I communicating? Just add the relative distance at atomic masses. Sodium 23, chlorine 35.5. If you add it, it will give you 58.5. You've settled the sodium. Let's go to the substance. You don't give us the I factor of fluorescing sodium. They did not give us. You are expected to get it by yourself. They only told that they've given you the information you need. That is a 3 ion what? Electrolyte. And it dissociates 80%. What should it be? For a 3 ion electrolyte that dissociates 80%. 2.6. True or false? So I factor of the substance is what? Is what? 2.6. They gave us the molecular weight of the substance as what? As of fluorescence sodium as what? 376. Right? 376. With this, you can get the E value of fluorescent what? Sodium. So we say that from the formula, E value is what? Molecular weight of sodium chloride, which is what? 58 point what? 5. Divided by I factor of sodium chloride, which is what? 1.8. Times I factor of the what? Fluorescent sodium is what? 2.6. Divided by 3.3 what? 76. Punch this in and tell me the answer. 0. What? Is that what you got, Ezekiel? Punch it something. Let's confirm. Let's be sure. Punch it too. Yeah, yes, you can. Yes, you can.
But can you divide each of them?
You can multiply this and this, divide by this. Also, you can multiply this and this, divide by this. Whatever you get, you still divide it by this one. You get some answer. Is that your question? Okay, what's the question?
You divide this one now, get this answer. Divide this one, get this answer. Multiply.
You still get the same answer. What do you get, Ezekiel? You got 0 point what? 0. Ezekiel, I got 0.22473. What did you get, Gideon? 0.2245. Whatever, just the answer. You can leave the answer as simply what? 0.23. It's okay. Okay? Leave the answer at what? 0. What? 23. This will become 5. 3. Is it clear? This will become 5. 3. So leave the answer at what? 0.23. So the E value of this is what? 0.23. Now I want you to solve question using what I've explained in this thing now. Solve question 8 and question 11. They're simple. They're not difficult to solve. Solve question 8 and 11. And 10, sorry. Oh, is that in 10 or 11? 10, okay. Huh? Question what? Question 8. 1.8. Is it to Ezekiel? You agree? I also agree because it says, number 8 says zinc sulfate is a 2-ion electrolyte dissociating 80% in a certain concentration. Calculate its I factor. After the dissociation, we have 20, 80, 80, right? Which is 180 divided by what we have before, which is 100%, which is now what? 1.8. I agree with you. That's the answer. What of number 10? The answer is 0.156. That is 0.16, right? It's correct. It's correct. Using the formula, it's correct. It's 0.16. So we're done with it. Let's go to this question. Let's go to this question. This is 3 and 1. Okay? 1, 2, 3. So we'll solve it then. We'll call it a day. Then I will now tell you how the rest of the revision will be like. Okay? Okay. All right, the question says, determine if the following products are hypotonic, isotonic, or hypertonic, right? Good. A, an ophthalmic solution containing, is it 4.0, Hezekiah? Is it 40 or 4.0? Okay, 40 milligram per ml of what? Chromoline what? Sodium. And 0.1% of what? Benzalkonium chloride in purified water. B, a parenteral infusion containing 20% weight in volume of mannitol. C, a 500 ml large volume parenteral containing dextrose water 5% of anhydrous, okay, 5%. Dextrose D5 water, which means 5% weight in volume of anhydrous dextrose in sterile water for what? Injection. For you to solve this question, you should know the sodium chloride equivalent of each of these drugs. So I'll list them out. Sodium chloride equivalent of chromoline sodium. Put it down. Put it down. Sodium chloride equivalent of chromoline sodium is 0.11. 0.11. Sodium chloride equivalent. That is the E value, right? Label it properly so you know what you're writing. Sodium chloride equivalent of this thing. Then sodium chloride equivalent of mannitol. Mannitol is 0.18. 0.18. Sodium chloride equivalent of benzalkonium chloride. Benzalkonium chloride is 0.16. sodium chloride equivalent of benzalkonium chloride is 0.16. Then while sodium chloride equivalent of anhydrous dextrose, sodium chloride equivalent of anhydrous dextrose is 0.18. We need these things to solve this question. If you don't know these things, you'll not be able to solve the question. 0.18 anhydrous sodium, dextrose is 0.18. Now remember when we discuss isotonic solution, we said that isotonic solution has the same tonicity with the what? With the body fluid, lacrimal fluid, body secretion, so that some of these infusions, injections, eye drops should be isotonic with the body fluid to avoid causing problem. Remember your osmosis. When you place a cell in a solution at a highly more concentrated than the content of the cell, what will happen? It will do what? Water will leave the cell and go out, and it will shrink, true of us, because water osmosis, water will leave from the region of lower concentration to the region of higher what? Solid concentration. So if you place a cell in a highly concentrated solution, so it will shrink. But if you place a cell in a hypotonic solution, a solution that has lower concentration than a cell, water will leave the solution and enter the cell, true of us, and cause trouble. To avoid such problem, you need to do what? Make sure that whatever you are introducing in this part of the body should have the same tonicity, so that there will be no such happening under normal circumstances. Okay, so that's the idea. And we normally use 0.9% sodium chloride as our standard, as an isotonic what? Solution. That's why you keep hearing sodium chloride equivalent, because of the sodium, because it has been discovered as 0.9% sodium chloride solution is what? Isotonic. Now we also bring it here now by saying the one we know that because you start from the known to the what? Unknown. That's why they compared these things with sodium and get the E value with a sodium chloride and get their E value. They will not use their E value in solving question, in balancing them or adjusting their what? To tonicity, so as to be okay with the system. But because they just want us to test, the question wants us to just test. The question is not asking us to make it isotonic. They want us to just test whether it is what they are. Just like you are working in a pharmaceutical company where you are manufacturing this type of thing. After this thing, you want to use their concentration to test whether they are isotonic, whether they are fit to be used in the body. That's what they want you to test here. So this is a person. They are not asking us to make it isotonic. There are some questions they will ask to make it what? But this one, they want you to say whether it is what or not. Then if you now want to, if we want to, we can now decide if it is hypertonic, we look for a way to make it isotonic. If it is hypotonic, you not look for a way to make it what? Isotonic. But the basic thing is that to know whether it is hypertonic or what? Isotonic. Yes, I saw it. This should be hypertonic. I saw it. Thank you. Now let's look at this thing now. A says ophthalmic solution contains. See what this ophthalmic is for the eyes, right? See what it contains. It contains chromoline sodium 40 watts milligram per watt ml. It also contains benzalkonium what? Chloride what? 0.1%. Now look at this thing. See what you will do. We need to really use the sodium chloride equivalent of these things to find out whether it is what? Isotonic or not. Now remember the one we know that the isotonic is what? 0.9 gram of sodium in what? in 100 ml. See what you will do. See what we will do. Are we together? Are we together? We will bring this thing. This we will change this to be in 100 ml. Gram in 100 ml. That will convert that of chromorin to be gram in 100, because the one we are working with is gram in 100 ml. Okay, so we will convert this chromorin sodium. We will move it from 40 milligram per ml in 1 ml, because that's the meaning, right? To gram in 100 ml. This one is already this is bezaconium, which is 0.01. It's already. I will use BC for bezaconium, okay? Okay. But are you aware that BC is already 0.01 gram in what? 100 ml. So this has no issue. But we need to use the sodium chloride equivalent of benzaconium to move this to become like sodium chloride. Because this is just the mass of the amount of benzaconium. The volume is the same thing. But we will change this thing using the sodium chloride equivalent of what? Benzaconium to check what it is in sodium chloride form. Okay? Because don't worry, we will take it one after the other. Let's convert this one to be in the same format, okay? Before we start working on the weight. This is 40 milligram for what? CS, right? CS is chromonin sodium. For CS is what? 40 milligram in what? In 1 ml. True of us. But this, we want to move this volume to what? 100 ml. Move this weight to what? In gram. Convert 40 milligram to gram. What is the answer? That you divide by what? 1,000. So this is taken as saying 0. What? Hope you remember this step I took. This is taken as saying what? 0. What? Is this 0. Check where? 0.40 divided by 1,000. 0.04 gram in what? 1 ml. You say 1 ml. If we have 0.04 gram in 1 ml, how many will be in 100 ml? You call it what? S. True of us. So S is now what? Multiply. Just simply multiply 0.04 gram by 100 ml, right? Times what? Divided by what? 1 ml. You cancel ml. 0.04 gram times 100 is what? 4 what? Gram. Is it clear now? So we succeeded in having that BC is what? 0.01 what? Gram in what? 100 ml. And the CS, which is chromorin sodium, is what? Is what? 4 gram in what? We are moved to 100 ml. In 100 what? Ml. Perfect. Now, but remember we want to compare it with sodium. Am I communicating? See what we will do. You know, these two things are in the same system, they are in one product. We will use the sodium chloride equivalent of chromorin sodium. Okay. Yes, because we are working in 100 ml here. No, I'm saying now, look at our standard. It's in 100 ml. The standard is in what? 100 ml. And even the bezaconium there is in what? 100 ml. So let's move it, everything to be in 100 ml. So we can compare it with this sodium chloride. Let me tell you the truth. Let me now give you the main thing. For this thing to be isotonic, the equivalent of chromorin sodium and bezaconium there, total of them must give you 0.9 gram. Because we want to move them to what? Sodium chloride now. Using sodium chloride equivalent. Using their sodium chloride equivalent. If you use sodium chloride equivalent of a substance, you can move it to what? Sodium chloride. Is it clear now? Because that is the amount of it that can be what? Have the same isotope. So you move it to what? Sodium chloride. So if you use sodium chloride equivalent of chromoline and move it to sodium chloride, and use sodium chloride equivalent of benzalkonium and move it to sodium chloride, and add two of them, they must give you 0.9 gram in 100 ml before they can be called isotonic. If they are below 0.9, they are what? It is what? The product is what? If it's below 0.9, it's isotonic. If it's above 0.9, the product is what? Hypotonic. But if it's 0.9, it is what? Isotonic. With this idea, now let's solve this question. Look up. We are sustained in getting this right. Now let's look at sodium chloride equivalent of what? We do it individually. Sodium chloride equivalent of benzalkonium benzalkonium chloride is what? 0. What? I can clean here, right? Yes. We are done here. Sodium chloride equivalent of benzalkonium chloride is what? I give it to you now. What is it? I gave you E value of benzalkonium chloride. What is it?
0.16.
Good. E value of what? BC, right? Is what? 0.16. What does this mean? What this mean is this. That 0.16 gram of sodium chloride has the same 0.16 gram of sodium chloride has the same tonicity with 1 gram of what? Benzalkonium what? Chloride. Is it clear now? Now, if 0.16 gram of sodium chloride is equivalent to what? 1 gram of what? Benzalkonium chloride, right? We have the mass of the weight of benzalkonium chloride here as what? 0.01. We now bring it here. 0. What? So let's move this 0.01 to what? Sodium chloride. Is it clear now? We now want to move it to what? Sodium chloride. So if you move it now, we call it what? X, right? Good. X is now equal to what? 0.16 gram times what? 0.01 gram over what? 1 gram. What's the answer? X is what? Can you see the board? 0.16 gram times 0.01 gram is what? 0. What? 0.016 gram, because this is just 1 now. So if you move this amount of benzalkonium chloride to sodium, this 100 milligram, what this means is that 0.0016 gram of benzalkonium chloride in 100 ml of it's now sodium, right? In 100 ml, right? Now let's work on what? CS using the same pattern. Don't forget the E value of what? CS. Don't forget the E value of what? CS. What is the E value of CS? Chromoline sodium.
0.11.
So using the same format, if the E value of chromoline sodium is 0.11, what it means is that 0.11 gram of sodium chloride is equivalent to what? Well, good, perfect. 1 gram of what? Chromoline. So we write it. 0.11 gram of what? Sodium chloride is equivalent to what? 1 gram of what? CS. With this now, let us now move this 4 gram of CS to what? Sodium chloride. Let's do it. So that means 4 gram of CS is now what? X. So X is now what? 0.11 gram times what? 4 gram over what? 1 gram. Gram will cancel one of the grams. So we just multiply 0.11 gram by 4. 0.11 gram by 4. What's the answer? I think it should give you 0.44. So it's now what? 0.44 gram. So in that system, in that product now, actually, sodium chloride in that product is what? 0.44 gram plus what? 0. So add two of them. Add 0.44 gram to 0.0016 gram. It must give you 0.9 for it to be what? Isotonic. Up to 0.9 is not isotonic. What's the answer? 0.44. So it's less than, it's just half of this, right? So it's what? It's what? Iso. Iso is when it's equal to this. Is hypotonic. So this option, the first A is what? Hypotonic. It's not iso. It's not hyper. It's what? Hypotonic. We are coming. That's number C. Okay, 0.18. 0.18. Mine is still 0.18. When you are done copying, I want you to use the idea I use in this first one to solve B. It's simple. Let me check how far you can go down your own. Which one? What do you get? 3 point what? Gram in 100 mil. You use the sodium chloride equivalent, everything, right? So that means, do you think, from your result now, do you think it's isotonic or hypo or hyper? It's what? Hyper. Okay, let's see now. Solve your own. Ezekiel, let's see. Gideon, if you are too sad, you can even try this C part. Equal. I don't with your own. What? The first one is what? What do you get in the first one? 3.6. So is it hyper? It's hyper, right? So indicate it that it's hyper because it's above 0.9 gram. Okay, so solve this second one, this last one. Let's see. Check where? Check what you did. 100 mil. That is where your error came from. Ignore that 500 mil. Whether it is 1 liter, whether the distilled water is 1 liter, whether it is 500 mil, they have the same 5%. True of us? It's not true. Whether normal saline is 1 liter or whether it is 500 mil, the concentration is still what? No, I mean normal saline is still what? 0.9. It's not true. So ignore that. Don't even put that. There's a type of question you'll be asked. You can use that one, but in this one you don't need it. Just work with that 5% straight and get your answer. Gideon has got 0.9 gram. Let's Hezekiah finish. Let's see. I will make you appreciate what you have been doing in the hospital since now. All this thing you've been dispensing. I want you to appreciate it now. What's that? Okay. You're not done. So it's what? Isotonic. Do you now see why 5% distilled water is isotonic? This is what you dispense now. This is what you dispense now. It's not 5% distilled water you dispense in the hospital. So this is what the calculation they do after the production to ensure that it will be okay with the system. These other ones are hyper.
So that means, if any question comes from maybe 5% mannitol, we know that it is isotonic.
Now, wait. They say 20% what?
Dextrose are like 5% dextrose.
Is that what?
Like what I'm trying to say is that like in the hospital with them 5% dextrose.
Yes.
Mannitol.
Yes.
I think dextrose.
Yes. Then
all I had like only is 5% dextrose. Dextrose I'm on a dispensing. That one is isotonic.
It's isotonic.
Then all I require another question related to if I dispense it.
Okay.
That means that it is also isotonic.
It depends on concentration. Hope you know there are some infusions that are meant to. There's something all infusion must not always be isotonic. Maybe there's something they want to treat. Sometimes they want to treat. They want water to leave the system. Maybe in edema, they can apply hypertonic solution. So water can do what come out. True of us. So it depends on what you want to what you want to treat. So you can use hypertonic, but you must be intentional about what you are treating. So you believe everything that's entering the system must be isotonic. Depending on the part of the system is entering and what you want to achieve. Like now, this one normal saline, and so normal saline, this one water. You want everything to be at. So you should isotonic. There are some things they will infuse in some patients. The medicine is to take care of edema, accumulation of water. They want water to just leave the system, so they can apply such thing hyper, so that water will come out. You know, when they say sorry about a hypertonic solution, then water will do what? Leave. True of us. Yeah. So all these things are just manipulation. What you want to achieve, but basically, this water 5% is what? Isotonic. Great is laughing. So a patient that use this thing for a long time, a patient that use this thing for a long time in the eyes will have issue. Now we got here to be what everything so present in this thing we got is what? 0.016 grams. If they now ask you what is the amount of sodium chloride to be added here to make it isotonic, what should be the answer? A question can come like this.
You minus this from 0.9.
Good. And not the remaining one. Simply do 0.9 minus this. Is it clear? And therefore saying that is the amount of sodium chloride, and once you add it, it becomes
just to make it
isotonic. Yes. You know it's hypo.
Yes.
This basically this one is hypo 0.016 gram. It's far below 0.9 gram. So the amount of sodium chloride that you want to add there to make it isotonic, simply subtract this from 0.9. The remaining one is the amount of sodium chloride you add, and once you add it, it will become what? There's a question you will see formula. What's the amount of sodium chloride to be added? This is what you need to do and get your answer.
Thank you, sir.
You're welcome. Sometimes there's a question you will ask. You will see them ask you the amount of boric acid. No, it's not every preparation that you need to add sodium chloride because of some certain issues. Now, sometimes they may use boric acid. They may ask you what is the amount of boric acid to be added. It's so simple. Once you have determined the amount of sodium chloride to be added, use sodium chloride equivalent of boric acid. Bujje sodium to what? Boric acid. Because sodium chloride equivalent of boric acid is 0.52. Put it down. Sodium chloride equivalent of boric acid is 0.52. What does it mean? That 0.52 gram of what? Sodium chloride is equivalent to what? 1 gram of what? Boric acid. True of us.
Boric acid, sodium equivalent of boric acid
is 0.52. Always write the e-value so that this will not confuse you. Sodium chloride equivalent, that is e-value of boric acid. Just put equivalent there so you will know that you are talking about the equivalent. So sodium chloride equivalent of boric acid is what? 0.52. What does it mean? That 0.52 gram of sodium chloride is equivalent to what? 1 gram of what? Boric acid. So if they ask you the amount of boric acid to be added here to make it isotonic, first of all, check the amount of sodium chloride you added. If you check it, you bruise it to what? Boric acid. Since you know that 0.52 gram of sodium chloride is equivalent to 1 gram of boric acid, therefore this amount of sodium chloride will not be equivalent to how many gram of boric acid. You get it. That is the answer. In case you live here somewhere else and you see question like that, you know exactly what it's all about. So I think we'll stop here for now. We'll continue next week Sunday. And please, we are done with isotonic situation. Please look for the other topic. By God's grace, if you can, let's see how many questions we can cover within 2 hours. So we'll get start from topics that has larger number of what question. Okay. So if you come next week, you look for another topic that has which one? Is there another topic that has 12? So we do concentration next week. Good. We'll start with concentration next week. Let's see how far. If we finish the 12 questions within 2 hours, we enter what? Dilution. So we'll start with concentration next week. Okay? All right. Okay. Thank you very much. See you. All right.